Hey, Talpinaline's Math and History, and we're going to be identifying the equations. So in this video, we're going to solve some equations, but we're also going to prove how we got those answers, because your school might be really focused on how did you get this answer? How can you prove you got this answer or that answer? Well, this video is going to help you understand how you got that answer. In the last video, we were discussing and reviewing the properties and operations. So in the last video, we were talking about the names of each move in math and what their abbreviation is, because each abbreviation and each move can be used as a step towards solving or simplifying a problem. Let's see an example where these names and these abbreviations would apply. So, we have a graph right here, or actually a table. One side has the word equation, and the other side has the word phase. The equation is going to be what the math problem is on right here. Then, the phase is going to tell us what to do in order to solve that problem. That is where these abbreviations are going to be put in, our phase. So let's get started. What happens if we have this problem? 5 parentheses x plus 3 minus 2x equals negative 21. What we're going to try and do is try to get x alone, like an answer like x equals 3, for example, or x equals something. So, we're going to solve this as normally, but understand how we got that answer. So this is called our given phase, because when we have a problem on an assignment or a test, the problem is going to be given to you. So this is what you're going to be trying to solve. That is called a given phase. The next phase is actually something that we do to solve the problem. What we can do is distribute the 5 to the x and the 5 to the 3. And when we take a look at our names of our moves and our abbreviations, what we just did is the distributive property. So that abbreviation is called dp. So our next step is to write dp, because that means that we did a distributive property move. Then we'll get an answer of 5x plus 15 minus that by 2x equals negative 21. So pretty much what we did is we got a step closer to getting an answer as x equals something. What we can do next is combine like terms, because we have that 5x and that negative 2x. And if we take a look at here, combine like terms is abbreviated as CLT. So what we can do is write CLT right here and make that math move. So 5x minus 2x is going to be 3x plus 15 equals negative 21. There is still some stuff that we're going to have to do to this problem. What we got to do is have that 15 and minus that by 15 on both sides. And we call that move the subtraction property of equality, or SPE, as a abbreviation. So, if we write SPE here, when it's addition, it becomes subtraction. So 15 minus 15 is going to be 0. And negative 21 minus that by 15 is negative 36. So now we have 3x equals negative 36. But the problem is, we want to have that variable isolated. What we're trying to get is a variable and a number as x equals whatever, x equals something. So, what we're going to have to do is divide both sides by 3. Because what we're going to do is a move called the division property of equality. Every time that there's a multiplication in here, we're going to have to divide so we can reverse that. So we can write DPE, division property of inequality. That is the abbreviation. But the thing is, in order to do that, we're going to have to do a simplify phase. Simplify does not have an abbreviation, so you'll probably have to write that out. So with our simplify phase, 3 divided by 3 is 1. Negative 36 divided by 3 is negative 12. So pretty much, x is going to equal negative 12. And that's when we simplify to get from here to there. And we are finished. Negative 12 is going to be x for this example. When solving and identifying the equations, it's pretty much playing Yu-Gi-Oh! Because when you're playing Yu-Gi-Oh!, there are also phases that you are going through every time you make a move in Yu-Gi-Oh! Here's an example. There is a draw phase, a standby phase, a main phase 1, a battle phase, main phase 2, and an end phase. When we're identifying the equations, we do not have an end phase, because when we simplify, that's usually going to be our end phase, bringing us to x equals a number as our answer.
My turn. Here I go. It's my turn. I draw. From my hand, I activate a spell. Let's do this. I summon a monster in attack position. Battle. All right, you asked for it. I attack with my monster.
Not over till it's over.
Take this. My monster attacks your life points
Not over
directly.
till it's over.
I end my turn.
All right.
But this is pretty much kind of related, because every time you make a move in Yu-Gi-Oh!, there's a phase that happens. And every time you make a move in identifying the equation, there's a phase that happens as well.